Hello and welcome to the solutions video for our December 16th assessment. So again, the solutions video has the questions for all outcomes individual students. We'll only see questions for 3 of these. And in fact, there's a couple of these that do listed in this section that do not appear on this assessment because nobody signed up for them. So let's take a look here. The slope of a line passing through -5, 7 and 3, -3 is, express your answer to 1 decimal. All right, so we're going to apply our formula, change in y over change in x. That is not super easy to read. Let's try changing that up. So the slope is y2 minus y1 over x2 minus x1. In this case, let's make the -5, 7.2. That makes 0.1 our 3, -3. As we discussed in class, it actually makes no difference which order we do them in. It just changes the sign on numerator and denominator, which will cancel. So then we have our 7 plus 3 on the top, and a -5 minus 3 on the bottom is a -8. So this is a -5/4. It did ask for 1 decimal, so -1.25 rounds to a -1.3. So -1.3. Next up, a line on a graph has a rise of 4 units and a run of 3. Well, rise over run is 4 divided by 3. Again, we're asked for a decimal, so we have permission to use them. 4 divided by 3 is 1.3 repeating, so that's C. Which of these line segments are parallel? So we have A goes from -4, 0 to 0, 4. So it's a rise of 4 and a run of 4. This CD has a rise of 5 and a run of 4. EF is 4 and 4. So A, B, and EF are the same. And then GH is much lower. You could probably even eyeball it to say, if we know there's a pair that are the same, you could probably just look at it without doing the math and go, well, A, B, and CD are going to meet. But EF looks like it might be parallel. So determine the slope of a line that would be perpendicular to this. All right, so to find a perpendicular slope, that's the negative reciprocal of the slope we have. The slope we have is 3. We have a rise of 3 and a run of 1. So the negative reciprocal of 3 is a -1/3. It's option D. Now the slope of a hill is 0.60. Which of the following would be a possible rise and run? So in other words, which of these has a rise divided by run? That works out to 0.60. That's our 3, 5 combination. The others would be 2, 1.2, or 0.6 repeating. Now here, how many of the above relations are linear relations? Notice in each case we have the same x values that always go up by 2. If the x are always going up by the same amount, it'll be linear if the y's always change by the same amount, either always up or always down. So our first one, up 4, up 4, up 4, up 4. So the first is a linear relation. The second, up 1, up 3, up 5, up 7, not linear. Third, no change. This appears to actually be the x squared relation. So not linear. So far we still just have one linear relation. Now up 6, up 6, up 6, down 3. We have to check all the points. It started out looking promising. It is not linear because of that 714 at the end. So only one of these is actually linear. Now, the following list of numbers represents a relation. What value of c would ensure that this is a linear relation? So our points are 2, 7, 3, 9, 5, c, and 6, 15. So let's graph this. Might make it easier to see which is the linear relation here. So our first point is 2, 7. Then we have 3, 9. Now, to make this a linear relation, we should have the same change. 2, 3, 4, 5, 6 should go up by the same amount every time. So I go 2, 3, 4, 5, 6. We'd go up by 2. There's 11. Going up by 2 would be 13, and another 2 would be 15. We check. Yes, 6, 15 is on there. So 13 is the one that fits the pattern. If we zoom out so we can actually see the points, it's a little more apparent. Slope is 2. So this looks like the linear relation y equals 2x. And maybe 4 is our y-intercept. Nope, a little less than that. Maybe 3. Yes. Yx plus 3 seems to be our linear relation. If you're not comfortable matching them, it doesn't work in a test because you don't have Desmos access. But the tilde allows you to have Desmos actually do the curve fitting. So if you say y equals mx plus b using the one subscripts, it'll pull it from the data table. And then that also tells you slope is 2, intercept is 3. Regression is not technically part of the provincial curriculum until Math 30-2. There are ways to do it on your calculator, but this is how you can do it in Desmos. Number 7, which of the following describes a linear relation? The speed of a passenger on a roller coaster. Okay, so if it's a roller coaster, you'd expect that speed to be highly variable, sometimes positive, sometimes negative, going back and forth. That would not be linear. A rental car company rents for $140 per day and charges $60 for insurance. Cost of renting a car for 3 days, that would be a linear relation. The population of a bacteria colony doubles every hour. That means if we start with 1, then we have 2, then we have 4, then we have 8, then we have 16. So that's not linear. And the height of a basketball as it arcs up and down in a pass would also not be linear because gravity is always accelerating it. We don't have a constant speed. How did we identify this answer? So 140 per day. The per day part implies that's a slope. Right. Each day we add the same amount. That's a constant slope. $60 for insurance. That's a flat rate. So this actually fits our y equals mx plus b form as y equals 140x plus 60. So if we wanted to fill it in, it would be 480 for the 3-day rental. Next one. Given this relation as a set of points, what is the domain? Well, the domain is the allowed x values. So we're going to have a 2, a 7, a -2, and a -5. In order, that's part or option D. Now, we have more domain and range here. Minimum value of the domain. That's the lowest x value. In this case, it's -1. And the maximum value is +1. Our line segment is horizontal. The maximum value of the range and the minimum are both 4, because 4 is the only y value allowed. This one, minimum value in this domain is a -1. The maximum value is the x-coordinate at the far right-hand side, which looks like a 3. The minimum value in the range is a -7. And the maximum value is a 2. We are just reading these coordinates right off the graph. Now, given this relation, 2, 8, -1, -4, what is the range? That's the list of allowed y values. So in order, we have a -4, a 0, a 3, and a 5. Here, again, minimum value in the domain is a -4. The maximum value in the domain, the highest x value allowed, is a +8. Then we have minimum and maximum for the range. The lowest range value is here. That's a -4, and the highest is a +2. That's a typo. It should be a 2. So now let's determine the value of the following function, g of x. This is a function notation question. G and then 0 in the brackets means what's the value of g when x is 0? Reading off the graph, that's 9. When g is 6, or when x is 6, our y value is 1. When x is -3, our y is 0. When our x is 3, our y is 5. So now, given the equation here, -48x squared plus 42x plus 2, the value of f of 6. So this is 1, where we are substituting. So we have a -48x squared plus a 42x plus 2. Sorry, I didn't mean to put that extra horizontal line there. Okay, so we have a -48 times 6 squared plus 42 times 6 plus 2. -48 times 36. And 42 times 6, 6 times 2 is 1, carry the 1. 252 plus 2. And then a 48 times 36, 8, carry the 4. 28, carry the 2. So we have a 1,728, but that's negative. So we'd be subtracting 254 from that. That's a 4, that's a 7, and that's a 4 and a 1. So we should have a -1474 here, if I have done this correctly without a calculator. All right, so our next one. The profit that Stephanie makes in her honeybee farming business is a function of the number of hives that she has. Her profit is given by this equation, P of n equals 8n minus 12. What does P12 equal 84 mean? Well, if it's a function of the number of hives, then the number in bracket is the number of hives. So we have to have 12 hives. It's actually this one. The profit for owning 12 hives is $84. Now here, given this equation, g is -87x plus 42. If g of x is -828, find the value of x. So we have a -87x plus 42. I thought this should be a little thinner. Oh, yes, that's why. The zoom is off. That is why my whiteboard marker doesn't look like a whiteboard marker. Okay, let's try it again. -87x. Don't need the maximum width. Let's do regular. So a -87x plus 42 equals, and our y value here is -828. If we bring the 42 across, we have a -87x, a -828 minus 42 is a -870. Divide both sides by -87, and we get that x is 10. Now here, what is the value of f of -2 minus f of 3? Well, f of -2 is at 5, and f of 3, 1, 2, 3, we go down, that's a negative 5. So 5 minus negative 5 is 10. Now, which table of values represents the equation x equals 3? In that case, we're going to have a vertical line. If we turn off these and we graph x equals 3, we have a vertical line through 3. So we'll have a wide variety of y values, but only the one x. So that is D. Next up, which of the table of values represents the equation y equals 3 times x minus 100? Well, if x equals 10, 10 minus 100 is a negative 90 times 3, that's a negative 370. So A is out. If x is 100, y is 0. That works. 101 times 3, yeah, 102. So 2 times 3 is 6. This one seems to be holding up. If we try this one, 110 minus 100 is 10 times 3, y would be 30. And 105 minus 100 would be 5. 5 times 3 is a positive 15, not a negative. So it is B. Now, Kelly works at a bowling alley. Shoe rental is $5 and it costs an additional $7 per game played. So the cost of bowling, we're going to have something that starts at 5 with a slope of 7. So we actually have a couple of entries that seem to fit that. It's actually B and C. They both start at 5, and at 7 they're up to 12. So how do we decide which it is? Well, we're not going to bowl half a game, or if we do, they're going to charge us for the full game anyway. So the number of games that we bowl is going to be a whole number. 0, 1, 2, 3, 4. We're not going to have pi games. So is this data discrete or continuous? It's discrete, so it's either A or D. And the reason is you can only play a whole number of games. It's not because money is available in all denominations. Money is also discrete. You don't generally charge 0.007 cents. So which graph represents the following table of values? So 0, 6, we're going to have a y-intercept of 6. That narrows it down to B and D. And then 2 is 8. We have an increasing. 2, 8, 4, 10, 6, 12, as opposed to this decreasing value. What is the lowest common multiple of 6 and 8? Our calculators can do that without a calculator. Multiples of 8 are 8, which is not a multiple of 6. 16 is not a multiple of 6. 24 is a multiple of 6. That's the first multiple of 6 on the list from 8. The other way, 6 is clearly not a multiple of 8. It's less than that. 12, not a multiple of 8. 18, not a multiple of 8. 24 is. 24 is the number on both lists. 48 is a common multiple. It's not the lowest common multiple. Now, the greatest common factor of 84, 210, and 336. If we've got the proper calculators, that can do that for us. If you have the TIs, you pick any two, get the greatest common factor of those two, and then take the greatest common factor of the answer and the third number. The Casios do allow you to put all three in at once. They can comma separate those. Let's do this as though we don't have the calculator. 84, 210, and 336. So let's use our Euclidean algorithm. 336 minus 210 is 126. 210 minus 126, this will be 4. We've already borrowed or carried that one. Regrouped, so 0 minus 2, we have to regroup again. And that is a difference of 84. So, it's tempting to stop there because 84 is the third number on our list. But we don't know it's the least common multiple of these two. We have to keep going till we get to 0. So we have 42. 84 minus 42 is 42. Now, 42 minus 42 is 0. So 42 is the greatest common factor of 336 and 210. And it's also 2 times 84. So if we do our next step, the greatest common factor, sorry, I'm just going to undo that. It didn't start writing right away. 84 minus the 42 we had from our previous one. That's 42. And 42 minus 42 is 0. Really, that third check is this process right here. So 42 is our greatest common factor. So you could, in theory, check these because, yes, they're all multiples of 2. Is that the greatest one? Yes, they're all multiples of 210. Or 21. 21 times 4 gives us 84. Times 10 gives us 210. And to get to 336, it's 21 times 8. So, but notice, 4, 10, or, sorry, 2. No, I was right, sorry. The multiples are 4, 10, 8. Those are all even numbers. There's another factor of 2 there. 42 times 2, 42 times 5, and 42 times 4, or no, 42 times 8 to get to the rest. But anyway, 42 is our greatest common factor. Now, prime factorization of 17,424. Again, we could just take our calculator and start with the first one we recognize, say a 2, and go divide by 2. How many times can we factor a 2 out of that? Well, it goes into this 8, 7, 12. Divide that by 2. And it goes in 4, 3, 5, 6. Still even. Divide this by 2. 2 goes in a 4 once. Goes in, or 2 goes in a 4 twice. 2 goes in a 3 once. 2 goes into 15 7 times, and 2 goes into 16 8 times. We're still even here. 2, 1, 7, 8. 2 goes into this once. Goes into 1 0 times. It goes into 17 8 times, and it goes into 18 9 times. So, we have our first factor, 2 to the 4. There's 4 factors of 2 that we pulled out before we got to an odd number. So, 2 to the 4. Our next base. Okay, let's work on these now. 1 plus 0 plus 8 plus 9 is 18. That is a multiple of 3. So it's divisible by 3. 3 goes into 10 3 times. It goes into 18 6 times. It goes into 9 3 times. Still a multiple of 3, which we could have expected since 1089. When we added that up, that's 18, which is a multiple of 9, or 3 squared. Divide it by 3 again. 121. So here we go. We have 2 factors of 3. And 121, we are looking for a third prime base. So what factors does 121 have? Sorry, when the internet is slow, this doesn't write that well. It's a web-based whiteboard. So 121, if we run through all the prime factors less than or equal to its square root, well, we might even see that its square root is 11. But we can see it's not even, not divisible by 3, not divisible by 5. We could check if we have to, but dividing it by 7 gives us 2 remainder. So it's not divisible by 7. The next one to check is 11. And yes, 121 divided by 11 is 11. So we have 2 factors of 11 here. That finishes our prime factorization. Would be a little bit faster using a calculator, but it's doable. Now, determine the cube root of 42,875. So let's take a look here. If it's going to go in as a whole number, the fact that it ends in 5 says it's a multiple of 5, so we've got to be able to pull some 5s out of it. Let me just double check. 42875. Okay. So how many 5s? If we can't pull out 3 5s, it's not going to work. Divide it by 5 once. 5 goes into 42 8 times. It goes into 28 5 times. It goes into 37 7 times, not 5. And 25 5 times. If we divide this by 5, 5 goes into 8 once. It goes into 35 7 times. Goes into 7 once. Goes into 25 5 times. Here's our third 5. So 5 goes into 17 3 times. It goes into 21 4 times. Goes into 15 3 times. No longer multiple of 5. We have our 5 cubed. It's not even. These digits add up to 10, which is not a multiple of 3, so it's not a multiple of 3. Our next prime to check is 7. 343 times 7. Well, 7 goes into 34 4 times, leaving us with 63 remainder. 7 goes into 63 9 times. And 49 is 7 squared. So that's 1, 2, 3 factors of 7. So this number is 5 cubed times 7 cubed, which means the cube root is 5 times 7. Obviously, the proper calculator can make that much, much easier. We just plug that 42,875 in there and take the cube root. Now we want to match the points of the image above with the square roots below. Root 46, well, root 49 is 7, so this will be a little bit less than 7. Looks like 0.5. Might also be 0.4, but that's much closer to 6, depending on the scale. We'll have to double check that. Root 30 is a point between 5 and 6, because root 25 is 5, root 36 is 6, so that'll be 0.3. Root 17 is just over 4, because root 16 is 4. So that looks like 0.2. And then root 40, that would also be between 6 and 7, but much lower than 46. So that would be 0.4. Next, express this as a radical. X to the 3/4 squared, well, something with a power raised to a power, we multiply those powers together. So that's 6 over 4, which is 3 over 2. And that's the square root of x cubed. Now, which is equivalent to the 8th root of t. Well, an 8th root is the same as having that as the denominator in your exponent. So that's t to the 1 over 8. And we are getting close to the end here. We express this as a power with a single exponent. Well, 10 over 2 is 5. So that gets us down to either b or d. A negative exponent brings it up to the numerator. So we have x cubed times, or x squared times x is x cubed. Here, we want to simplify this expression, first expressing it as a single power. Okay, let's take a look at x to the 3 over 5 times x to the 6 over 5, I believe we had. Yeah. So when we have power times power with the same base, we add those. So this is x to the 9 over 5. That's our first part. So as a single power, we have x to the 9 over 5. And then expressed as a radical, that's the 5th root of x to the 9. We have that 5th root button, x to the 9. Next, one of the factors of the completely factored form of 81x to the 4th minus 16. Well, this is a difference of perfect squares. Sorry. So 81x to the fourth minus 16. 81 is a perfect square. Even exponent makes it a perfect square. 16 is a perfect square. We have that subtraction sign between them. So this is the square root of 81, x squared, minus the square root of 16, times the square root of 81x to the fourth, plus the square root of 16. Notice, it says completely factored, and 9, x squared, and 4 are all still perfect squares. So we're not done. We don't have a 9x minus 4 because it started with the fourth. We have to keep going. We factor this 9x squared minus 4 as the difference of perfect squares. We have 3x minus 2 times 3x plus 2 times 9x squared plus 4. We cannot factor the latter as the difference of perfect squares because of that plus sign. The difference of difference of perfect squares means you must be subtracting. So 3x minus 2 is the only one of these factors that appears on that list. So now numeric response. When 4x squared minus x minus 5 is factored in the form 4x minus b, x plus d, we need the value of b and d. And we have a hint here in that we have to have a 5 and a 1 because that's prime. They already told us it's 4x and x, not 2x and 2x. That saved us some time. They even match the negative and positives for us. So if that 4x were to be multiplied by a 5, we'd have a 20x minus x here, which would give us a positive 19x. We don't have that. So the 5 can't be in position D. It's got to be position B. Right. We're looking at factors that multiply out to 5, so this is either 15 or 51. Those are the only two possibilities. And the 4x minus 5 times x plus 1 gives us 4x minus 5x. That's our negative x and the negative 5. Now, one factor of 6x squared plus 13x minus 28. Again, we'd have to go through the factors of 6 and the factors of 28 to build the possibilities. They've already done that because it's multiple choice. We see every combination uses either 2, 3, or it's some combination of 2 and 3 to make 6, and some combination of 4 and 7 to make 28. We just have to figure out which of those combinations with which sign in the middle would give us a positive 13. So, either the 2x pairs with the 4 as a negative, the 2x pairs with the 4 as a positive, and our negative is in the other one, or the 2x pairs with the 7. These are the only 4 possibilities we need to check. One of them is going to give us that positive 13 we're looking for. As it turns out, you'll notice, if you look carefully, don't expect everyone to notice this, but I'm going to bring it up. These ones here, these factors have a common factor of 2, which means you could factor a 2 out of the whole thing. If that's true at one step, it has to be true at all of them, so we'd have been able to factor a 2 out of all of this. We can't because the 13 is positive. That means we can cross out these top 2 possibilities because they don't have that common factor. It has to be 2x paired with the 7. So, what are our cross terms? These both give us a 6x squared at the beginning and a negative 28 at the end. The negative 7 times 3 is a negative 21x plus 8. This one gives us a negative 13x. Positive 21 minus 8 gives us the positive 13x. If you hadn't noticed that common factor, that's totally okay. It is not an expectation of this course by any means whatsoever. But if you had not noticed and multiplied it out, you'd have had a positive 14 minus 12. So that's a positive 2x or a negative 2x. And now that we know to look for it, we can easily see there's that common factor of 2 all the way through here. So anyway, it is this bottom one, the 2x plus 7, 3x minus 4. That's the one that produces the result we're looking for. All right. So we have, looks like 7 left. So if we factor this completely, which one of the following is one of its factors? So we have a coefficient of 1 on our x squared, which means we're looking for numbers that multiply out to 24, add up to 11. It ends in a positive sign, so we have to have x minus in both cases. We're going to minus sign in the middle, so we have, that's why we know it's minus in both cases. So it's 3 and x, which of the following is one of the factors? Now this can be confusing because there are actually 2 right answers. I intend to make that as an announcement. If I forget, I apologize. But yes, this one does have 2 right answers. Either C or D will be marked correct. We have that same issue here. Except remember, the solutions are when the whole thing multiplies out to 0. So here we'd have factors of x minus 3 and x minus 10, which work out to 0 when x equals 3 or when x equals 10. That's what our solutions are. So you have that sign change. If we substitute in a 10, 100 minus 130 plus 30 is 0. Or 9 minus 39 plus 30 is 0. So positive 3 and positive 10 are the 2 solutions. All right, our last 5. These seem to be our relation and function questions. So a student examined these 4 mappings, which represent various relations. How many of the relations are also functions? If a relation is a function, that's because one x coming in produces exactly one y coming out. So nothing on the x side can have 2 arrows coming out of it. Mapping A has 2 coming out of negative 8, so that's not a function. Mapping C has everything coming out of negative 8. That's not a function. But B and D are both functions because they each have 1 arrow coming out. Which of these is a function? Here, the x value of 3 is associated with 2 different y values, 4 and 3. Not a function. Here, 1, 3, 5, 7. No repeated x's. That's got to be a function. And our 2 graphs each fail the vertical line test, so neither of those can be functions. Now, which statement is not true? All functions are relations. That is true. Every function is a type of relation. Each function has its own rule that is often given using function notation. Yes, that is true. That's the equation of the function. All relations are functions. This is the one that is not true. You can have a relation that describes a circle. For example, the x minus 3 is an example of a relation that's not a function. A circle. If we want a circle centered at, say, 3, 4, we go x minus 3 squared plus y minus 4 squared. If we want a radius of 5, we make it equal to 5 squared or 25. And there we have a circle of radius 5 centered at 3, 4. So we go 5 units right, left, up, or down. We're hitting the circle. 5 units away from that in all directions is part of the circle. This is a relation. It is not a function. And a relation is a function if each value in the domain corresponds to exactly one value in the range. That's the definition of a function. So that's true. Now, which one of these is not a function? So we have to see which of these produces multiple points of y. That's actually the equation that doesn't specify y at all, because it'll be true as long as the x is true. If we subtract 3, we get 3x equals 20 or 24. Divide by 3, we have x equals 8. This would be a vertical line through x equals 8, and vertical lines are not functions. So turning these off again, you can even delete them. If we graph 3x plus 3 equals 27, we get a vertical line through x equals 8. Our final question. The relations that are functions are relations. It can't be A, because that has 2 values associated with 5. So it's got to be C and D, because everything else includes A, and the only other alternatives are C and D. And that's functions because each X input has only one corresponding Y output. That's the definition. Just to double check, relation B has 2 entries for -3. Relation C, we have 2 entries for 1, but they both are 1, -1, so it's still a function because there's only one Y associated even though the X is repeated. And D passes the vertical line test. So now, quick pause to make sure that there's nothing wrong on the answer key here. Yeah, it looks okay, so we can submit. Now that I've marked the written response, and here we go, the perfect score. It's 45.05. You'll have that 0.05 if you did A and 1, because our question on factoring here, let me see, I just have to scroll till I can find it. Actually, you know what? I can do it much faster if I just hit show, and it jumps to or highlights in blue those questions. So this question here are A to the B, C to the D, E to the F. That is marked as 0.15 per, or yeah, it's marked per digit, and we have 7 digits. So just had to come up with something close to it. So each digit is scored as 0.15. And these are the solutions to the December 16th assessment.